A fluid motion is given by V equal to y plus z I cap plus z plus x j cap plus x plus y k cap. Then prove that the motion is irrotational and find the velocity potential. We know motion means velocity. So velocity is irrotational means the curl of the velocity must be equal to 0. If you prove that curl of velocity equal to 0, then motion will be irrotational. To find the curl of the velocity, mathematically we will write curl of velocity is equal to cross product of the velocity vector with the del operator. This is your del operator. So cross product of velocity vector with the del operator can be written as del operator is I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z, and the velocity vector is given y plus z I cap plus z plus x j cap plus x plus y k cap. You can write this in determinant form: I cap, j cap, k cap, partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, and you have I component y plus z, j component x, z plus x, and k component x plus y. If you find out the determinant, then for I cap component, you leave this column and this row. So partial derivative of x plus y with respect to y, the first term, minus partial derivative of z plus x with respect to z. So this is the second term. Similarly, you find out for the j component, that means if you write minus j, then you leave this column and this row. So you have partial derivative with respect to x, partial derivative of x plus y with respect to x in the first term. The second term, partial derivative of y plus z with respect to z. So partial derivative of y plus z with respect to z. Then for the k component, you have k cap, you leave this column and this row. So partial derivative of x plus y with respect to x, you leave this row and this column. So partial derivative of y plus z plus x with respect to x, the first term, minus partial derivative of y plus z with respect to y, the second term. If you find out the partial derivative of x plus y with respect to y, this will be equal to 1, and for this partial derivative of z plus x with respect to z, this will be minus 1. So first term will be equal to I cap 1 minus 1, minus for the second term, this term, minus j cap partial derivative of x plus y with respect to x is equal to 1, and partial derivative of y plus z with respect to z, this is equal to 1, so 1 minus 1. Similarly, for the third term, k cap partial derivative of z plus x with respect to x will be equal to 1, and partial derivative of y plus z with respect to y is equal to minus 1, and this will cancel. 1 minus 1, 1 minus 1, 1 minus 1. So the right hand side will be equal to 0. So the curl of the velocity vector, that is del cross v, will be equal to 0. Since del cross v equal to 0, v will be irrotational. Then it is given to find the velocity potential. You remember, to find the velocity potential, why we will find the velocity potential? Because for irrotational motion, a velocity potential function exists. That is why we will find out the velocity potential. Suppose the velocity potential function is equal to phi. And we will find out the velocity potential function phi. That means the velocity potential function must not be equal to 0. Okay, then how to find the velocity potential function? Velocity, to find the velocity potential function, let v equal to the grad phi. Suppose v is equal to grad phi. So grad phi dot dr will be equal to v dot dr. Okay, then find out v dot dr. V is equal to, it is given y plus z I cap plus z plus x j cap plus y plus x plus y k cap dotted with dr. Dr is equal to I cap dx plus j cap dy plus k cap dz. So if you find out the dot product, I cap dot I cap is equal to 1. So this term will be equal to I plus z dx. Similarly, j cap dot j cap will be equal to 1. So this term will be equal to z plus x dy, and the third term will be equal to x plus y dz, because k cap dot k cap will be equal to 1. So this will be equal to y dx plus z dx plus z dy plus x dx dy plus x dz plus y dz. And rearranging the terms, this will be equal to y dx plus x dy. I have written x dy here, plus z dy this term, plus y dz this term, plus z dx this term, plus x dz. Okay, and v dot dr or grad phi dot dr is equal to d phi, and d phi is equal to partial derivative of phi with respect to x into dx plus partial derivative of phi with respect to y dy plus partial derivative of phi with respect to z dz. This we have proved in your gradient. You watch the previous video for the gradient, that how you can prove the grad phi dot dr is equal to d phi. So here this term can be written as, the left hand side can be written as d phi, and the right hand side can be written as derivative of xy plus dyz plus dzx. Now if you integrate both the sides, in the left hand side you have integration of d phi is equal to phi, and in the right hand side you have integration of dxy plus integration of dyz plus integration of dzx. So phi will be equal to, if you integrate these terms, it will be equal to xy plus yz plus zx plus c, where c is a constant. So you see, you have a definite value of phi, that is velocity potential function exists. So here we have proved that motion, that is velocity, is irrotational by proving that curl v equal to 0, and we have also found out the velocity potential function.